In this video, we are going to configure a point-to-point connection. Or more accurately, we're going to break a point-to-point connection. So I have set up a positively massive network here in GNS3. It has two routers connected with a serial link. Even though these Ethernet links are connected to the Ethernet interfaces on these routers, they're not actually configured. So here are the west and east routers, and I literally booted these routers up and went in and configured the serial connections. You'll see all I did was apply an IP address and unshut the interface. And I did that on both of them, and that's all I've done. And by default, we should be running HDLC. So let's look at our serial interfaces on both ends, and let's see what they look like. So we'll do show interface serial 0/0. And you'll see that the serial is up and up, so the physical link is up and the protocol is up. And you'll see by default that we are using HDLC. And again, that goes back to our discussion that HDLC is the default for serial links. You'll notice that the link is actually working. We're actually sending and receiving packets. We're not getting any errors, which I would really hope we're not getting any errors considering this is all virtual. And in fact, let's ping the other IP address. If we do show IP interface brief, we see that this is 192.168.1.2, so we'll do ping 192.168.1.1, and we can actually ping the other router. If we go over here to east, it should be 192.168.1.1. We can actually do show CDP neighbor. Since this is a layer 2 connection, a direct connection, we actually see the other router on the other end. And we'll get into CDP a little more elsewhere in the course, but it's a good troubleshooting tool because CDP works at layer 2. If we go over here to the east and we do show interface serial 0/0, it says it's up and up. And again, it is also using HDLC because obviously they have to match on both ends. The keep alive is set for 10 seconds, so that will come in handy later on when we break this connection. We can also ping the other direction here, ping 192.168.1.2. It pings, we do show CDP neighbor, and we see the west router from the east router using CDP. So as advertised, let's break this connection. Again, by default, we're using HDLC. So what happens when we try to enable PPP? So let's go on the west router and do it there first. So we'll do config T, we'll go into interface serial 0/0, and the command we're looking for, if I just hit question mark, you see all of the commands here. The command we're looking for is encapsulation. Encapsulation sets the encapsulation type for an interface. So let's see what encapsulation types are available to us in this particular iOS. So we'll do encap and hit question mark. There's all kinds of different encapsulations. There's frame relay, HDLC, LAPB. To be honest, the only three I have ever used in my entire career are HDLC, which is the default. I've used PPP and frame relay. Now maybe that's just a symptom of the fairly non-complex networks I've worked on, but I've been lucky that everything's used IP so far. So if we do encap and hit PPP, if we hit question mark, that's all we can do. We can set the encapsulation to PPP. So if we do encapsulation PPP on this serial interface, and we wait a few seconds, this link should actually come down. So there's the line protocol. It already came down because now the frame types don't match on both ends. The east router will take about 10 seconds before it realizes that, hey, I'm not getting my keep alives back, and it will bring the connection down on that end as well. If we do show interface serial 0/0 now, we see the link is up, but the line protocol is down. You'll see that it is configured for PPP. LCP is in the listen state. So it's listening for an LCP packet to come from the other end. And you'll notice that now east has brought its line protocol down as well. If we do show interface serial 0/0, we see it's up, down. Encapsulation is HDLC, but you're not ever going to send any data across it because you're using a different encapsulation. So this proves that HDLC and PPP are not interoperable with one another, just as we predicted. Obviously, when you're dealing with networking, it's a good idea to hard code any settings like this on both ends. So let's go over on the east. We'll do config T, interface serial 0/0, and we'll do encap PPP. And exit out. And after just a few seconds, the line protocol should come back up, and it did. And if we actually hit the up arrow, we see that LCP is now open. So it recognizes that the link is open. The link control protocol says the link is open, and now it's able to use the NCPs, the IPCP and CDPCP, the IP Control Protocol and the Cisco Discovery Protocol Control Protocol. This allows both of those layer 2 and layer 3 protocols to flow across this PPP link. Again, we go over to the east, we do show interface serial 0/0. We should see exactly the same thing, and we do. It is encapsulation PPP, LCP is open, and we are using IPCP and CDPCP. And just to prove that it does work, we can do show CDP neighbor. We see the west router, and let's look at the interface IPs over here. So if we do ping 192.168.1.2, we're able to ping the west router from here. So we've successfully brought the line protocol back up. And that's pretty much all there is with configuring a basic point-to-point connection. Obviously, it can get a little more complex when you talk about PPP authentication and PPP multi-link and so on and so forth. But for the CCENT, that's all you really have to know for the exam. And that concludes our discussion of configuring point-to-point protocols.